Hey everybody, this is Alex Merced from alexmercedcoder.com, and in this video what I want to do is just go through a quick tutorial of how to create a RPC API using gRPC, which is a Google framework, to make it much easier to create an RPC API. I am going to be releasing an episode of my Web Dev 101 and Data Nation podcast where I go over in depth like what is RPC and all this stuff. So, and then also this article here, I kind of get into it. So I'm going to defer you to check out that podcast. So do subscribe to the Web Dev 101 and Data Nation podcast on Google Play, Stitcher, or iTunes and Spotify. Subscribe to this YouTube channel while you're watching. So click the like button and hit subscribe, please. And then again, there's my blog over there at alexmercedcoder.com. You can find my blog, and you can find this article there. I'll have a link in the video description for more of like the whys and the whats of gRPC. So here we're just going to develop it and just kind of see it in action. I'll talk a little bit about it as we go. So what I'm going to do is I'm going to create a new folder. I'm going to just close all these terminals for a second. Create a new folder. We'll just call it, call it example. So we'll call it gRPC example. Okay, and that's what we're going to work out of. So I'm going to create a new terminal. I'm going to cd into that folder, cd into gRPC example. And what I'm going to want you guys to do, and again, the blog article has the steps so you can follow. So I'm going to skip through all the sort of me explaining what everything is, and I talk about what GraphQL is, what REST is. It's a really good article. I highly recommend checking it out. Okay, but we're going to just create a new node project, npm init-y. Okay, and we're going to install the libraries we need. So for Node, we're going to need two libraries. We need npm install at gRPC / gRPC.js. So this is like the JavaScript implementation of the gRPC framework. That's what that library is. At gRPC / proto loader. Okay, this we're going to be creating what's called a proto file very soon, and this library is what's going to handle loading that file. Okay. So we do that, and so that's going to install there. And then what we're going to do is we're going to create three files. Okay, so the idea here with an RPC API is that the actual how does this API work with, like what are the different things it can do, are all defined through the proto file. The proto file is just like sort of this like universal source of truth of how this service works. Now that proto file then needs to have a server implemented, meaning we have to actually describe okay, the proto file tells us that there's these actions that we can do, these functions that the service can do, but how those functions actually work depends on the server implementation. Okay, the beauty of that is you can have multiple implementations of the same proto file. Okay, and that's where Apache Arrow is going to come into play in a little bit. And the thing is that the same client can communicate with all implementations, so you can have the same different servers implementing the same proto file, and the same client would work with all of them because they're all meeting the same sort of definitions. This will make a lot more sense once you actually see this in action. So we're going to create three files. One is going to be our server.js. That's going to be for our server implementation. We're going to have a service def or service definitions.proto. The proto file could be called whatever, but has to end in .proto. Make sure you install a protobuf VS Code extension. So I installed protobuf support. That was the extension I installed. Okay, so that way you get the syntax highlighting and all that stuff. And then we're going to have our client.js. So that way after we implement our server, that's going to determine sort of how do we communicate. So again, client always means the thing that's sending the request, server is the thing that responds to the request. Okay, because at the end of the day, that's all of our applications that we build can be servers and they can be clients. Just depends on the context of which application is talking to who. Okay, that's what APIs are. Application programming interfaces. They are ways for different applications to interface with each other. Okay, we could do it through REST, we could do it through GraphQL. RPC is another option. And again, you'll see when you would probably want to use RPC very soon. Okay, so let's see here. Let me create these files. Okay, those files are created. So if I open up over here, we can see all our files are created. My package.json has the two libraries installed. There we go. Everything is looking good. So the first thing I want to do is I want to go to my proto file. That's where, because first we have to define what is our RPC API look like. Okay, that's what the proto file does. Okay, so again, here in the blog post I linked to where you can read up on the Proto Syntax. But basically, you start off by just at the beginning declaring like what the syntax for this file is going to be. So Proto 3, because again, there's also Proto 2 for older APIs. So this way it knows what it's parsing. And you're going to want to define a message is like, if you've ever done the GraphQL API, in GraphQL APIs, there's types. Okay, or really like in any language, you might have heard of typing, where you have to define the types of data inside your application. Same thing here, except the types of data are called messages, because the idea is you send these things, the service can send and receive these things. So one type of message is going to be empty. This is just going to be sort of like an empty argument, meaning we don't need to give any information. So this just means an empty object. That's literally all that means. What we're going to do is we're going to create a service that literally just sends you back the name of a dog. Okay, keep it real simple, just so you can kind of see this at its like simplest implementation. Okay, and I'm going to say a dog has a string name, well, string called name. That's the property. So any dog that is going to be used in this service has to have a name. That's a string. And then each field has to get a number. Okay, so you just have to give it a number, 1, 2, 3, 4. Generally, you want to prioritize like the more important fields first, because the later fields will take up more memory. Bottom line is just 1, 2, 3, 4, 5. Okay, and then I'm going to have an integer. So I'm going to do a 32-bit integer, which is going to be called age. So the age of the dog, and that'll be field number 2. So there we go. We've defined what a dog is. Okay, and then what's going to happen is that my API can have multiple services. So think about it this way. A service would be like kind of like you would have, like if you were doing a REST API, you would have a bunch of routes under generally like a namespace. So like /dog may have a bunch of routes like /dog/ update or something like that. There would be a bunch of like different REST URLs or REST endpoints there under that dog, and then maybe you have a separate batch for cats. The idea is that each service should be a separate bundle of things you can do that are related. Okay, so in this case, we're going to create a service called dog service. You can create as many services as you want, but the idea is that they should generally have like a theme. So the dog service, in this case, and then RPC is how we designate like one sort of endpoint, so one function. And this is going to have one action called getDog, or one procedure. Procedure is another word for function, because again, this is called RPC stands for remote procedure call. So you're basically invoking a function remotely. That's essentially the concept here. You're saying, hey, there's these functions that are defined on the server over there. I would like to go invoke it by name, which is essentially what you're doing with GraphQL or REST. You're invoking a function that's defined elsewhere. It's just the mechanism of how you do it. In REST, you make a request to different APIs or different endpoints that trigger different functions. In GraphQL, you use one endpoint, and you use you use your GraphQL syntax to tell what query, and then it determines what function to run from there. Here, we're going to set it up in a way where you're not explicitly making an HTTP request, so it's going to feel like you're just calling a function, and it just knows that, hey, this function actually lives on the server, and it just does the thing. Okay, RPC getDog, and now getDog receives empty. Okay, so basically there's no arguments to it. Okay, so basically as an argument it only receives empty, and then returns, and in return we'll get a single dog, not a bunch of dogs. If I wanted many dogs, I would have to create like another message called dogs that has like a field that like repeats dog, because repeats is kind of how you designate like a collection of items. It's a keyword in the Proto Syntax. Okay, that's it. That's it. So we've defined a way to get dog. And now what happens with this proto file, other people can create their own servers using this proto file, and people can have a bunch of these APIs that give you back a dog. They just may give you back different dogs. Okay, so with this, I can now implement the server. So let's head over to server.js, and let's start setting up the server. Okay, so we're going to load our dependencies. Load dependencies. And first thing we have to do is bring in gRPC, because again, gRPC is the framework. Require at gRPC.js. And then we want to bring in the proto loader so we can load the proto file. Equals require at gRPC proto loader. Okay, so now we got those into place. Now the thing is that you do need a proto file. So in order for you to implement a client or a server, you do need the original proto file. Okay. So typically, like in a situation like this, I would implement the server, and then I would probably create a library as a client. So that way, whoever the individual user is doesn't have to worry about, getting a proto file and doing everything I'm about to do right now. Someone would just create a client library that just makes it just easy to connect. Okay, that'll just kind of work. So path to our proto file, and we'll just say const proto file. And again, you can name the variables whatever you want. They're variables. Equals / service def dot proto. Okay, service def dot proto. Okay, cool. So that's just that's just a string that tells us where that file is. Now what's going to happen is that when we load the file, there's certain options that you just kind of need to have in place. So I'm just going to literally just copy and paste this right here from the docs here, or from my blog post. And essentially all this is just their options. Okay, cool. And things like basically just things that will determine how it loads the proto file. Okay, I haven't read the docs in deep to know exactly what each one of these do. I imagine this just means keep the keep capitalization, the capitalization in the proto file, and then just like how you define certain things. Okay. Okay, cool. So now let's load the proto file, because again, that's how it knows what the definition of your API is. So we'll call it like package definition. So package defs. So it's the definitions of our package equals proto loader dot load sync. So it's a synchronous. So there's a load, which is asynchronous. So then we have to use like, a sync await and all that stuff. So to keep it simple, we're going to use load sync. So that way it's loading it synchronously. And then I'm going to load in the direction to the proto file. So that's where the file is, and these are the options for loading it. Cool. So that loads the file. And now that we have this like loaded like object, that basically breaks it down to this object that we can then now pass to the gRPC framework. So that way the gRPC framework knows, okay, this is what our thing is set up as. Okay. So we load the defs into gRPC. So I want to say const dog proto equals gRPC dot load package definition, and then pass in the package defs. Okay, so essentially what it's doing is I'm loading the package definition. It creates like this object that actually has like sub objects for each of like the services. In this case, we only have one service we've defined. Okay, cool. And then we're going to create our server. Create gRPC server. Okay, and so we just say const server equals new gRPC.server. So that's just going to create the server object so we can turn on the server later. Get rid of the word apply there. This is not Scala. There we go. Cool. Nice. Okay, so again, all we've really done is just load up the definition of our API. That's all that's really done, and we have a server that now exists. It's not on, it's just it exists. Okay. So now what we want to do is we have to tell it how the dog service works. So we know that the dog service has this function called getDog that receives nothing and gives back a dog. How do you do that? Well, we're the server, so right now we're creating a server, so we have to implement the details of how that happens. Okay, so again, implementation is always like the details, like how does it happen? Okay, so the proto file is just giving us the signature of our API. In the server implementation, we define like the actual like guts of how those signatures, that contract is met. Okay, implement dog service. So we're going to just say, hey, server, we'd like to add a service. Do you want to add a service? Okay. And then what I'm going to say, hey, the service I want to add is part of that dog proto file. And in the dog proto file, there's a service called dog proto, or dog service, and we are adding the service, like the service object to it. Okay, and then what we do is we pass in an object, and then for each function that we had defined under the service. So if we had multiple functions here, I would define one property in this object for each method. So in this case, I would just say, in this case, it was only get dog. So I say get dog. And the way this function works, so again, each of these methods is just going to be a function, but the function is always like whatever like the input would have been. So in this case, it's really just empty. So this is just going to be an empty object. So the input is really just going to be an empty object in this case because that's how we defined it. And then the callback is going to be provided by the user on the other end. So the user is going to say, hey, when I do the thing, once you've done the thing, how are you going to deliver me the thing that you got me? Okay, in this case, a dog, because again, this service is going to return a dog, theoretically. So I need to implement that here. Okay. So what I'm going to do is I'm going to do sort of like what I would do is I would just do like a try catch block. So that way, in case something goes wrong. In this case, it won't because it's pretty straightforward. But try catch error. So I'll set up the try catch block. So they again try this code. If there's an error, the catch block would catch it. So assuming everything is going fine, we just pass callback. And the callback, the first argument that gets passed with the callback is an error if there is one. Okay, there is no error. In this situation, we're assuming there's no error, so we're going to pass null. So that way it doesn't think there's an error. And then the second argument, we pass in the payload, like what the thing that it should be returning. And according to my proto file, it should be returning a dog. And a dog, according to my proto file, has a name and an age. So I'm going to return an object that has a name, spot, and an age of 5. Okay, so there we go. Now again, in case there is an error, what we'll do is we'll say callback. And then instead of passing null, we pass back the error because we're assuming that an error happened. So maybe it was like, if we were fetching the dog from a database, maybe there was like an error in fetching it from the database, or something went wrong. Okay, callback error. And then the second argument, well, in this case, we didn't get the payload, so we would pass null as the payload because there should be no dog if there's an error. Okay, so there we go. We've implemented it. And again, if there were other RPCs, like other of these functions defined there, I would then just keep defining these in this object. Okay, so I'll save this just so that way it auto formats a little bit. There we go. And last, we just start the server. We're going to start the server, and then the server side of this is going to be done. Okay. Server.bind async. Okay, we just have to define where the server is going to be running on. So we're going to be running locally, 0.0, 0.1, say 5,000. Okay. And then you have to pass in how it's going to handle, how is this server going to handle authentication. So it's just going to be wide open. So we're going to say gRPC.server credentials. And then again, there's a couple different options here. So you can see here, it's like create and secure. That's what we're going to use. But you see this create a secure connection. There's other things in there. Okay. So I'm going to say create and secure. Invoke that. Okay. So that's meaning, anyone can make a request to the server. And then there's a callback, which the callback is just basically, hey, what happens when the server starts? So it receives the error and a port. So again, if there was an error in starting the server, that error would equal that. So we're just going to say console.log, listening on port, use interpolation to show the port. Okay, and then we start the server, server.start. There we go. And because we're binding the server and then starting the server. Okay, so that way it knows where should the server be exist. Okay, and then that's it. So now I can run this server. So I can just be node server.js. And that looks like I must have forgotten something. Expected legal token. Oh, I think I'm missing some semicolons here. Did I want one here? Let's see here, where did I miss the semicolon? Yeah, looks pretty similar. Throw error, illegal token, line 12. I guess it wants one right here. I didn't get that issue before, but we'll go with it. Let's try to run the server again. Yep, and now it's working. Okay. Oh, I see why. I forgot to include this little empty object there at the end. That's what I'm missing. So let me restart that server. There we go. Because technically it's like a function signature, so the idea is that it represents like the implementation of the function. Cool. Okay. So the server is running. Now we need to just implement our client so we can make requests to that server that's running on port 5000. Okay, and I'm just gonna kind of, just for the sake of time, I'm gonna copy and paste this and walk through it real quick. It's not a huge file. And again, a link to the repo with all this will be in the video description. But again, we're literally doing the same thing. We're loading up the proto file with the options. So all this stays the same. The only difference here is that when we get to the definition, instead of like loading up all the definitions, we're loading the package definitions and grabbing that dog service object right out of it. Okay. And then we're going to create a client from that dog service object. So we say new dog service, so we're initiating it, and we're saying, hey, the server that is implementing the service is here, and then here's like the credentials for like logging in. Again, we made it insecure, so we don't need anything there. So it just depends on the server on the other end, how the credentials need to be handled. Okay, so we implement that, and then we just and then basically the client will allow us to use the functions. Okay, so there's client, and again, what client, the first argument is technically the argument, so the input that would receive, which we just said empty, so it's just an empty object, and then we pass in the callback, and this function is what is going to get called whenever you see the word callback over here. Okay, so essentially what happens is that this function runs, and when it's done and gets me the dog, it's passing the dog there. Okay. In this case, I would either get an error or a dog. If there's an error, I want to console log error. But if there's no error, then that means things should have gone fine. So then let's console log dog, because there should be a dog if there was no error. And that's all it does. Okay, so now I'm going to open this up in another terminal window. So cd into gRPC example and do node client.js. Okay, oops, why doesn't it like? Oh, because it's a different port. So 5000 this time. So, and there we go. I get the dog. Okay, because he's connecting to the server. They both are using the same proto file, so they both know what I'm referring to. So when I say client.getDog, it knows I'm referring to, hey, this thing should have an implementation for getDog, and they're both implementing that same proto file. As long as that's the case, it's just gonna work. And I go notice, like I don't have to worry about like I don't have to worry about like HTTP verbs or methods, anything about HTTP at all. It just feels like I'm calling a function, and that's sort of the benefit of gRPC. But the other big benefit is like I said, I was going to mention Apache Arrow. Is that with Apache Arrow, which is like this specifically Apache Arrow Flight. Apache Arrow Flight is a specification of how to communicate, how to connect to a database and take advantage of the Apache Arrow format when you transport the data. So they have a proto file. So Apache Arrow Flight. Okay. So you see here, they have this proto file. Okay, so it's just like that proto file you just saw me do, except, with a lot more stuff in it. Okay. And the idea is this: any database that wants to take advantage of Apache Arrow Flight, what they would do is they would implement a server using this proto file. Okay, and the cool thing is, what they're doing is they're creating something called Apache Arrow Flight SQL, which is going to be the client. And so the idea is that client that can be they'll make for different languages, will work with any database that implements a server like this. And the beauty of that is, instead of having to have like a different client for Postgres, a different client for MySQL, a different client for Mongo, for any database that wants to take advantage of Arrow Flight, which is going to be more for like databases that focus on analytics, because it's about columnar formats. Check out the podcast episode on WebDev 101 and Data Nation for me to get more into that. But that one client should be able to communicate with any of those databases because they're all working from the same proto file. They're all working from the same sort of contract. And that's the beauty of it. Like, because in other previous standards, what would happen is that in each language, you would have to create a separate driver for each database in each language. And that's a lot of work. and that means more code to maintain. Here you can create one client library that is maintained, and long as the different servers that it communicates with all implement the same proto file, they should just work. So you only have to maintain one client library per language, and each server doesn't have to worry about maintaining their own client library. They just implement the server, and it just makes it easier to implement for everybody. So in a situation like that, it makes a lot of sense when you're creating sort of like this open standard. RPC is a really good way to kind of do it, because different people can implement that standard on the client and server side, as long as they all work from the same proto file. So that's gRPC and RPC. Hopefully this gave you some more depth on like what it is and why it is and what's cool about it. Again, a lot of those articles will be in the video description. Have a great day. I'll see you all later on.